So I feel like Microsoft is on a roll lately as I'm doing and covering another Microsoft paper. This one, Differential Transformer, put out by Microsoft Research and Tsinghua University. I'm hoping I'm pronouncing that right. Probably not. But so within this paper, it's very interesting overall. I'll go over it and I'll go in depth into it. But so you can see the metrics from the paper diving in very specifically. They improve the attention mechanism within transformers very specifically, and they eliminate noise within attention. And it's interesting the method that they utilize. And so this paper comes out on October 7th. The like uh, Google method for updating transformers that I did a video on that about a week ago. And then so there's this paper. I don't think that there'd be enough time in between that and that paper and this paper, but it's interesting because they're very similar tracks as to what these are doing, and very similar as to how they get to their results, right? Like, so exactly what differential attention does and how they get there. So, as a refresher for the Google paper, essentially what they do is they add additional layer to the model itself, and then within that additional layer it's a subtraction layer, and then it allows them to subtract essentially layers from the attention mechanism that aren't being utilized, and then this diffusion transformers utilizes and kind of builds on that same type of model, and then so this is just showing how effective it makes the needle retrieval of like the how focused the model is. I've shown these kind of charts before in my videos, so it should look kind of familiar to you, but you can see on the right hand side it's super green as opposed to some red and a lot of yellow there on the left hand side. So like it's looking really good on the right hand side, which is like that's they're showing off what they're doing here within their model. The paper is like 9 pages long, and then it goes into the references from here forward from page 10. But so I'll leave a link to the paper. Check it out. And so let's talk about and dive deep into like exactly what differential transformers is, because it's very straightforward, right? And then so essentially what we're going to do here, so we need torch, and then so we're going to utilize pytorch in this instance, and then we're going to utilize and define like very specifically like for this is like defining like the standard attention mechanism, and then we're going to split it into multiple heads, which we do with the with the standard attention mechanism as well, right? The standard attention mechanism is a multi-head mechanism out of the gate. But what we're doing is, in this instance, just very straightforward, is we're splitting the heads into two layers. And then, woo, right? And then it's like that same type of concept as the Google paper, right? And that's why I bring up the Google paper. It's because literally all this is doing is adding an additional layer. Woo, woo, right? Like magic, right? And it really is that straightforward. But like, what is interesting within this is that the layer that they're adding into this, it's addition by subtraction. And then so that's what makes it interesting, right? This additional layer that they add into the model, it allows for the model to subtract. And then so within that, it gives it the ability to, in this instance, utilize or subtract parameters that it's not utilizing within the attention mechanism, which it makes it a lot more efficient in this instance, and then and it allows for the attention mechanism to strip out and reduce the noise. So what happens is essentially within the model it creates one of standard attention standard attention layer, and then the other one is models the noise, and then the model subtracts the two layers from each other, and then by doing that it subtracts out the noise, and there you go is your final outcome. And then so we can see here that this is the math involved. It's essentially just splitting out the attention mechanism and then splitting it into two, and then recombining those two layers and recombining the results of the layers of the two attention mechanisms. So, I mean, to me, very straightforward as to the math. And then this is just printing out the size of the neural network that we've created in this instance. And then below, right here, I give you an example of a standard attention mechanism, right? Like, and then so you can see here we have the multi-head attention, just like we would. We have our feed forward layer, just like in the other one. And then all of this is we have our encoder and decoder. And then all of our layers, we get the same output here. We're defining our neural network size. It's the same neural network size, etc. The only difference is that this attention mechanism has only one layer as opposed to two layers with this attention mechanism. And then that's really it, right? So again, addition by subtraction, really simple as far as the end result solution, but very elegant to think of, right, and to put it together. But I think you're going to see more and more use cases for this, like kind of addition by subtraction, because this is the second time and the second company that has produced something along these lines with this type of model now. So I'll leave a link to this Colab notebook. If you like this type of content, please like and subscribe. Thank you very much.